Last time we defined a rational function. We also learned about vertical asymptotes, horizontal asymptotes, and the domain of a rational function. We did a couple of problems where we analyzed the functions, two rational functions. We graphed the functions and we tried to find these asymptotes in the domain. We're going to do a few more problems and we're going to look at the graph of the function compared to some information that we're going to find. Eventually, we're going to learn how to graph these functions. So here's the first one I want to look at. G of x is equal to 3x minus 1 divided by 5x squared minus 7x plus 2. So let's figure out the following information. What's the domain? What are the vertical asymptotes, if there are any? And how about the horizontal asymptotes? And we can also talk about the range once we look at the graph. But for the first three, we can find these just by looking at the equation of the rational function. Okay, so starting with the domain, remember that the domain is all the numbers that we can put into this function. And when we have a fraction like this ratio, the only time we have an issue with the domain is when we divide by 0. So when I ask you for the domain, what I'm really asking you to do is to find all the values that you can't plug into the denominator and take those out. So what we need to do is we need to factor 5x squared minus 7x plus 2. Now this is a quadratic. There's a few ways to factor it. You can use the quadratic formula, and that will give you the factors. What I'm going to do is I'm going to use my method of factoring, which is to take this 5 and this 2, multiply them together, put it down here. And this negative 7, I'm going to put at the top. And I need to think of two numbers that multiply to give me 10, add to give me negative 7. Well, 5 and 2 make 10, and they add to give me positive 7. So let's make them both negative. That negative times a negative will give me 10, positive 10. So since we found the two numbers, because this coefficient is not a 1, what we're going to do is we're going to take this negative 7x and make it negative 5x plus negative 2x. So down here, I have 5x squared minus 5x plus negative 2x plus 2. This is the same thing. You can see that negative 7x is now negative 5x plus negative 2x. Group the first two, group the last two, and factor what I can out of both. So I can take a 5x out and I get x minus 1. And then here I can take out a negative 2. And I also get an x minus 1. So you can see that I have an x minus 1 in both of these, so I factor that out. And then I get a 5x plus a negative 2. So this is the factored form. So what I'm going to do is I'm going to erase this, and I'm going to write it over here. So this is the same thing as 3x minus 1 over x minus 1, 5x minus 2. Okay, so let's erase this so it doesn't look so junky down here. Okay, now that we have this factored, let's ask ourselves what the domain is. Remember, it's things that we cannot plug in to the denominator. So notice that if I plug in a 1 here, I'll get 0. And if I plug in 2/5 here, I'll get 0. Again, what we do is we just take each piece, set it equal to 0, solve for x. And these are the two numbers we cannot equal, so x cannot be 1 or 2/5. So if you want to write this domain in interval notation, remember you start with the smallest number you can be. You can go out to negative infinity, all the way, well, the first number you got to take out is 2/5 because it's smaller than 1. So 2/5, take that number out, then go up. We have to take the number 1 out and go to infinity. So that's the domain. Now for the vertical asymptotes, all we have to do is we have to simplify this as much as possible. So if we have any common factors in the numerator and the denominator, we take them out. But notice that there's nothing in the numerator that's also in the denominator. So we don't have to factor this any further. So the vertical asymptotes just correspond to the factors in the denominator. So the vertical asymptotes, I'm going to put this one in green, it's x is equal to 1 and x is equal to 2/5. Notice that it corresponds to the numbers we had to take out of the domain, as long as that number wasn't also in the numerator as well. So these are going to be our vertical asymptotes. What about our horizontal asymptotes? So remember that how we can figure out the horizontal asymptotes is first we look at the degree of the numerator versus the degree of the denominator. Here, if we look at the original equation, the degree of the numerator is 1. I'm going to write that over here. So the degree of the numerator, I'm going to abbreviate it like this, is equal to 1. The degree of the denominator is equal to 2. Remember, if the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y is equal to 0. That's always true when the numerator degree is less than the degree of the denominator. So we found all of these pieces. Now let's graph the function and see what it looks like compared to these asymptotes. I'm going to just do a brief little sketch here just to get me started. So we have these vertical asymptotes at 1 and 2/5. So 1/5, 2/5, 3/5, 4/5, 5/5. This is 1. So what I'm expecting here when I graph this is that I'm going to have a vertical asymptote over here, 2/5, also at 1. And then I'm going to have a horizontal asymptote at y is equal to 0. So remember that horizontal asymptotes tell us the end behavior of the graph, what's going to happen. So we're going to approach, on the left side, we're going to approach this asymptote, and also on the right side. And then near these vertical asymptotes, we're either going to go towards a positive infinity or down towards negative infinity. So let's see what the graph looks like. I'm going to switch over to graphing calculator. Here we are. And now let's type in the function. So the function was r of x is equal to 3x minus 1 over 5x squared minus 7x plus 2. Okay. Now remember that the vertical asymptotes and the horizontal asymptotes are not actually part of the graph. They just help us sketch the graph. So if we look in a little bit closer, you can definitely see that something strange is happening. We're going up towards infinity. I'm going to zoom out. Let me even close this. You can see that definitely we're going up. If I zoom in, you can see out here at the end behavior, we're definitely going towards those asymptotes. What I'm going to do is I'm actually going to type in the equations of those asymptotes. So one of them was x is equal to 2/5. The other one was x is equal to 1. And then the last one was y is equal to 0. Now using these, you can see this blue line here, it's a green one, this one right here. You can see that our graph gets really close to it. In fact, we can't even see after that. If I zoom in, you can see a little bit better. Let me go like this. You can see that this red line is really close to that blue line, which is exactly what we expect with an asymptote. Same thing down here, this red line. If you click on it, you can see that it's getting really close to this blue line, which is what we expected. Also, it's getting close to this green line, so that is an asymptote as well. You can see that this red line is getting close to that green line. And then you can see that we cross the horizontal asymptote. But remember, that's okay to cross a horizontal asymptote. It's just the end behavior. We need to go towards that horizontal asymptote, which we do, and also on this side. So let's switch back to our screen here. So the graph kind of looked something like this. Went down like that. And then on this side, it went towards this one. It crossed and then went towards this asymptote. And then over here, the graph did something like this. So that's the idea of this graph. Okay, oh, and the range. So we wanted to talk about the range. Let's look back at our screen, the graphing calculator. Now remember what the range is. The range is all the values that y can take on. I'm going to get rid of these asymptotes real quick. Okay. So something to notice in our graph. Well, our graph, definitely for anything bigger than 0. If we're bigger than 0, we have points on this graph. So we're going to go all the way to positive infinity. You can see that if we zoom out, no matter how far up we go, we're always going to have a red line corresponding to that y value here. And the same thing down here, you can see that wherever this maximum is, which looks like it's a little bit smaller than -2, we're going to have values below that. So right here, I'm going to click on this. This graphing calculator lets me know what the maximum and minimum are of like parabola looking things. So we have that this -1.925 is a maximum. So anything below that, we've got values for on this red line. And then if we look at this graph up here, you can see that right here at this minimum here, which I think I can click on as well, this is going to be the lowest point of our graph, which is 0.123. But anything above that, when we are on 0, we have a point here, something here, something here. No matter where we click, we're going to have a y value. So it looks like our range is -infinity to this value, -1.925. And then we jump. We don't have any red marks in between these 2 points here. So that's -0.519. We're looking at the y value here. So then up to -1.925, jump, go to -0.5192 infinity. So let's write that as the range. Now notice that for that particular graph, without using a graphing calculator, it would be nearly impossible to figure out that range. Just want to mention that.